So in this video, we're just going to quickly introduce vectors. And so the big idea is that we have some quantities that we call scalars that can be characterized with a single number or a single measurement. So for example, things like weight, a single number tells you how much you weigh. Temperature, a single number tells you what the temperature is. Area, a single number can tell you what the area of an object is. Volume is a scalar measurement. 3-liter bottle. One number tells you the size of the bottle. Mass, how much stuff an object is made up of. Time is a scalar quantity. Speed is a scalar quantity. One number suffices to tell you how fast you're going. Vector quantities, however, are quantities that require two measurements essentially to completely characterize them. You need to know the size and you need to know direction. So typical things that are vector quantities are force, how hard am I pushing and in what direction am I pushing. Velocity, which is different from speed in that velocity has to have both the speed information as well as the directional information. And acceleration is also an example of acceleration. You need to know both the size of the acceleration as well as the direction of the acceleration to completely characterize it. So, for example, an airplane, we could use a vector to represent the velocity of an airplane. And the vector is just going to be a directed line segment. It's going to start at an initial point and it's going to end at a terminal point. The direction in which it's pointing is going to indicate the direction, and then the length of the vector, the magnitude of the vector, gives you the size of the thing. So in the case of a velocity vector, the direction of the vector tells us the direction the plane's going in, and if we were to measure the length of it, we would get the speed, which in this case is 300 miles per hour. Speed, 300 miles per hour by itself, is a scalar quantity. But when we have a vector representing velocity, the length gives us speed and the directed line segment gives us direction. The larger the speed, the larger the directed line segment. The smaller the speed, the smaller the directed line segment. So the vector contains both pieces of information in it. It embeds both pieces of information. Equivalent vectors. So the idea here is that if you have a vector of a particular size pointing in a particular direction, this vector actually represents the set of all vectors that point in that direction and have exactly that same size. There's a sense in which a single, when we have, say here I have 3 different vectors, each of which is the same length, each of which points in exactly the same direction. There's a sense then in which these are the same vector. The vector v characterizes all possible vectors that we can draw anywhere in the xy plane with that length and that size. So equivalent vectors, that's all it means. Same length, same direction, the vectors are equivalent. You just need a single vector to represent the set of all such vectors. When we're working with vectors, like I mentioned a little bit earlier, the point where you start the vector from is your initial point. And the point where the vector ends is the terminal point of the vector. And then if we give the points, the initial and terminal points, names, let's say we name the point 3 to capital P, and the convention in geometry is to give points in the plane capital letter names. Vectors get lowercase letter names, so this would be P, and this point we'll call it the point Q. If we're going from P to Q, initial to terminal, we would put the P first and the Q first, and then we would put the vector arrow over PQ. So the vector U right here could also be denoted as the vector from P to Q, the vector PQ. And the direction of the vector matters. So if I point the arrow in the opposite direction, so I have the same 2 points, P and Q, this is a different vector. It's the opposite of this vector. So if I have the vector W here from Q to P, W is actually the opposite of vector U, and we would denote this vector as the vector from Q to P. When you're looking in textbooks, they won't put the vector arrow over the vector notation. They'll just make the lowercase letter bold so that it stands out, and that will indicate in a textbook that it's a vector. When you handwrite, when you're drawing by hand, you always put the vector notation over the lowercase letter to differentiate it from just a lowercase u. A convention in geometry, for example, is to give things like lines or line segments letter names, and that's typically going to be done with the lowercase. So you need a way to differentiate a vector from a line or a line segment, and the arrow notation or bold notation in a book is the way that you do that.